So let's think about how we would write hypotheses for goodness of fit tests. We're going to talk about two different types of hypotheses, the no preference hypothesis and the no difference hypothesis. So we have two different null hypotheses depending on the situation that we have. So sometimes we have situations where we're comparing the preferences that people have. So in this case, we have a no preference hypothesis or an equal preference hypothesis. In other words, all of the options will be chosen at the same rate. There's another type of hypothesis that we're going to talk about, which is the no difference hypothesis. Sometimes we know what the percentages are in the population for certain categories, but they may not be equal. So if we know these percentages in the population, we can make a null hypothesis that our sample is no different from the proportions in the population. So let's take a look and see what this would look like specifically. So if we're doing a no preference goodness of fit test, that just means we're trying to figure out if some group is more popular than another group. And the null hypothesis is that the population is divided equally among the categories, that they're equally as popular. And the alternative hypothesis is that the population is not divided equally among the categories. So this is one type of goodness of fit test. In the no difference goodness of fit test, we have a null hypothesis that says whatever proportions we're seeing in our sample match what's in the population. So sometimes, once again, we know what those different proportions are in the population for a certain number of categories. And what we're saying is our sample is exactly like the population. The alternative hypothesis says that the proportions for the population that my sample comes from are different from the proportions known to exist in the population in general. So here's an example of this no difference hypothesis. So let's say that we know the breakdown of licensed drivers in the population. The ones that are under 30 are 28% of the population, and over 30 are 72% of the population. We might want to know if these proportions match those that are true for speeding tickets. If the null is no difference, then 28% of the speeding tickets are going to go to drivers under age 30 and 72% would go to licensed drivers over age 30. So this is an example where we know the breakdown in the population and we can compare a sample to that breakdown in the population. So let's do a check. Chi-square is a hypothesis that compares what? It's kind of a trick question because it's both population percentages or population proportions. You could write them either way. A marketing representative asks 120 customers to select the brand image that they prefer out of 3 choices. What would the null hypothesis state? Take a look at the answers here. And the null hypothesis would say a third of the population would prefer each brand, because we're saying in the null hypothesis there's no difference between the categories. Using public health data, a health psychologist examines whether there are differences in sexually transmitted infection rates based on political affiliation. The known affiliation for 4 political parties is 40% Independent, 10% Green Party, 30% Democratic, and 20% Republican. What would the null hypothesis for this no difference goodness of fit test say? It would say population proportions are no different from the known population proportions. And let's just be clear on what this means. When we say population proportions, we have a sample in front of us, but we're saying something about the population that the sample comes from. Remember, we always write hypotheses about the populations. We're saying that this population that my sample comes from is not different from this known population of proportions. Okay, perhaps it will be easier once we start actually looking at the formula for a chi-square statistic. That's coming up next.